Ground fault circuit interrupters, or GFCIs, are crucial safety devices designed to protect people from electrical shock. They work by monitoring the current flowing through a circuit and quickly interrupting the power if a ground fault is detected. A ground fault occurs when electricity flows through an unintended path, such as a person's body, to the ground. This can happen if someone touches a live wire or a faulty appliance. The GFCI detects this imbalance in current and trips the circuit within milliseconds, preventing serious injury or death. The National Electrical Code, or NEC, which is a widely adopted standard for safe electrical installation, has mandated GFCI protection in various locations throughout homes over the years. The implementation of these mandates has significantly reduced electrical-related injuries and fatalities. In January 1971, the NEC first required GFCI protection for receptacles installed near bathtubs. This was the initial step in recognizing the importance of GFCI protection in areas where water and electricity could create a dangerous combination. The reasoning behind this mandate was clear: bathtubs present a high risk of electrical shock due to the presence of water and the potential for electrical appliances, such as hair dryers or radios, to come into contact with water. By requiring GFCI protection near bathtubs, the NEC aimed to prevent accidental electrocution in these vulnerable areas. December 1975 marked a significant expansion of GFCI protection requirements. The NEC extended the mandate to include kitchens, bathrooms, and laundry areas. This expansion recognized that these areas, similar to bathtubs, also presented a high risk of electrical shock due to the presence of water and the use of electrical appliances. Kitchens often have sinks, dishwashers, and other appliances that can come into contact with water. Bathrooms, in addition to bathtubs, have sinks and showers, further increasing the risk. Laundry areas typically have washing machines and dryers, which also use water and electricity. By requiring GFCI protection in these areas, the NEC aimed to provide a more comprehensive level of safety throughout the home. In January 1987, the NEC further expanded the GFCI protection requirements to include outdoor areas. This was a crucial step in addressing the risks associated with outdoor electrical equipment and activities. Outdoor areas are exposed to the elements, including rain, snow, and humidity, which can increase the risk of electrical shock. Additionally, outdoor activities often involve the use of power tools, such as lawnmowers and hedge trimmers, which can be prone to electrical faults. By requiring GFCI protection for outdoor receptacles, the NEC aimed to protect people from electrical hazards while working or playing outdoors. December 1996 saw the addition of garages to the list of locations requiring GFCI protection. Garages often serve as workshops or storage areas where people may use power tools, work on vehicles, or store flammable materials. The combination of electrical equipment, potentially damp conditions, and the presence of flammable materials makes garages a potentially hazardous environment. Requiring GFCI protection in garages helps to prevent electrical shocks and reduce the risk of fires caused by electrical faults. January 2008 brought another expansion of GFCI protection requirements, this time including crawl spaces and unfinished basements. These areas are often damp or humid, and may contain exposed wiring or plumbing. Crawl spaces and unfinished basements are also often used for storage and may contain items that could come into contact with electrical equipment. The combination of these factors creates a heightened risk of electrical shock. By requiring GFCI protection in crawl spaces and unfinished basements, the NEC aimed to protect people from electrical hazards in these often overlooked areas of the home. Finally, in January 2014, the NEC mandated GFCI protection for all newly constructed or remodeled homes. This was a significant step towards ensuring that all new homes and renovations incorporate the highest level of electrical safety. This requirement means that all 120 volts, 15 amps and 20 amps receptacles in locations such as bathrooms, kitchens, garages, outdoors, crawl spaces, unfinished basements, and other areas where water or dampness may be present must be GFCI protected. This comprehensive approach provides a uniform level of protection throughout the home, reducing the risk of electrical shock for all occupants. The NEC mandates for GFCI protection have evolved over time to address the changing needs and risks associated with electrical safety in homes. By understanding the history and purpose of these mandates, homeowners can ensure that their homes are adequately protected from electrical hazards. It's important to note that GFCI protection can be provided in two ways. Firstly, through the use of GFCI receptacles, which have built-in ground fault protection, and secondly, through the use of GFCI circuit breakers, which protect the entire circuit. GFCI receptacles are typically installed in place of standard receptacles in areas where GFCI protection is required. They have two buttons, a test button and a reset button, which allow the user to test the GFCI and reset it if it trips. GFCI circuit breakers are installed in the electrical panel and provide protection for all receptacles and devices connected to the circuit. They also have a test button for periodic testing. Regular testing of GFCIs is essential to ensure that they are functioning properly. It is recommended to test GFCIs at least once a month by pressing the test button. If the GFCI trips, it should be reset by pressing the reset button. If the GFCI does not trip when the test button is pressed, or if it trips frequently for no apparent reason, it may need to be replaced. When choosing GFCI receptacles or circuit breakers, it is important to select products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. This ensures that the products meet safety standards and have been tested for performance. It is also important to choose the appropriate amperage rating for the circuit. GFCI receptacles and circuit breakers are available in various amperage ratings, such as 15 amps and 20 amps. The amperage rating should match the amperage rating of the circuit to which it is connected. In addition to the NEC mandates, local building codes may also have specific requirements for GFCI protection. It is important to check with the local building department to ensure that all applicable codes are followed. If you are unsure about any aspect of GFCI protection, it is always best to consult with a qualified electrician. A qualified electrician can assess your home's electrical system and recommend the appropriate GFCI protection measures. They can also install GFCI receptacles and circuit breakers safely and correctly. Improper installation of GFCI protection can be dangerous and may not provide adequate protection from electrical shock. In summary, GFCI protection is a critical safety feature that can protect people from electrical shock. The NEC has mandated GFCI protection in various locations throughout homes over the years, and these mandates have significantly reduced electrical-related injuries and fatalities. Homeowners should ensure that their homes are adequately protected by installing GFCI receptacles or circuit breakers in all required locations. Regular testing of GFCIs is essential to ensure that they are functioning properly. If you have any questions or concerns about GFCI protection, consult with a qualified electrician. By taking these steps, you can help to protect yourself and your family from the dangers of electrical shock. Furthermore, it is important to understand the difference between a GFCI and a standard circuit breaker. While both devices protect against electrical hazards, they do so in different ways. A standard circuit breaker protects against overloads and short circuits. An overload occurs when too much current flows through a circuit, such as when too many appliances are plugged into the same outlet. A short circuit occurs when there is an unintended connection between two wires, such as when the insulation on a wire is damaged. In both cases, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the electrical system. A GFCI, on the other hand, protects against ground faults. As mentioned earlier, a ground fault occurs when electricity flows through an unintended path to the ground. GFCIs are much more sensitive than standard circuit breakers and can detect even small ground faults. This allows them to trip quickly and prevent serious injury or death. It is important to note that a GFCI does not protect against overloads or short circuits. Therefore, it is important to have both GFCI protection and standard circuit breaker protection in your home. In addition to the locations mandated by the NEC, it may be advisable to install GFCI protection in other areas of the home where there is a risk of electrical shock. These areas may include wet bars, swimming pool areas, and hot tub areas. The specific requirements for GFCI protection in these areas may vary depending on local building codes. Another important aspect of GFCI protection is the use of extension cords. Extension cords can be a source of electrical hazards if they are not used properly. It is important to use extension cords that are rated for the intended use and to avoid overloading them. Extension cords should also be inspected regularly for damage and replaced if necessary. When using extension cords outdoors, it is important to use cords that are specifically designed for outdoor use and to protect them from moisture. It is also important to avoid running extension cords through doorways or windows, as this can damage the cords and create a tripping hazard. In addition to the safety benefits of GFCI protection, there are also financial benefits. By preventing electrical shocks and fires, GFCI protection can help to reduce the risk of property damage and liability. This can lead to lower insurance premiums and reduced repair costs. Furthermore, GFCI protection can help to protect valuable electronic equipment from damage caused by electrical surges. In conclusion, GFCI protection is an essential safety feature that should be installed in all homes. The NEC mandates GFCI protection in various locations, and it is advisable to install GFCI protection in other areas where there is a risk of electrical shock. Regular testing of GFCIs is essential to ensure that they are functioning properly. By taking these steps, you can help to protect yourself and your family from the dangers of electricity. Remember to consult with a qualified electrician if you have any questions or concerns about GFCI protection.